This short video is just going to go through this problem, which is problem number 11 on page 153 of your engineering textbook. This problem is basically saying we've got a hydraulic system here with a small area and a large area, and that hydraulic system is being pushed by a mechanical arm. So you're pushing the effort down here, and that's then transferring a force into the piston on the primary, and then that ultimately moves the secondary straight up over there. And so what I've been explaining to you in class is that if you get this problem, you need to recognize that there's two problems here. One, which is a hydraulic problem, force 1 over area 1 equals force 2 over area 2. And the second is a moments problem, which is this piece over here where there's a force being transferred around a moment arm. And I'm actually going to label that moment arm point A. So in this diagram there are two problems. Now I'm going to be focusing on the moment arm part of the problem because the hydraulic system's pretty easy, but I'll just quickly show you a calculation I've done on the hydraulic system section. Using the equation force 1 over area 1 equals force 2 over area 2 for hydraulic arm, this being force 2 and area 2, that being force 1 and area 1. All you need to do is, first of all, using the diameters that you've been given, calculate the area for area 1 and area 2, which I've done using pi r squared, and then plug those values into the equation. So in this equation, force 1 being the 7 kilonewtons you know, over the area 1 equals force 2, which is the downward force coming into the piston, over area 2, which is the area of the first piston. And if you work that out, you ultimately get to this answer over here, that force 2, the required force to get 7 kilonewtons coming out, is 174.5 newtons. So that's the hydraulic section of the question. We now move on to the force 2 over here. We've been worked out because we know that the 7 kilonewtons now requires 174.5 newtons downward force in order to get that 7 kilonewtons force coming out. What we now need to work out is how much effort over here is required to calculate a force 2 of 174.5 newtons. And that's where we're going to start off over here. So looking over here, this is 174.5 Newton force coming down the piston, and this is an effort that's being applied at the end of this arm. So this point over here is the pivot point, and I'm going to call that point A. And we need to now first of all make sure that we understand a couple of things. Firstly, we've been told this arm is at an angle of 30 degrees. Therefore, we can say that this line over here is at an angle of 30 degrees to this point here. If we understand our moment arms, we know that around a point at a perpendicular distance from a force, all the moments must add up to be 0. Which ultimately means that this force multiplied by its perpendicular distance from A must equal this force multiplied by its perpendicular distance from A. So what we need to do is first of all calculate out what is this distance 1 equal to. And if you look at the diagram, this is 40 millimeters. What we can clearly see is that 40 cos of 30 degrees is equal to distance 1. And so that gives us a rough distance 1 of 34.64 millimeters. Now that we know distance 1 is 34.64, it's quite a simple calculation where we're just saying, well, that distance multiplied by that force is equal to this distance multiplied by this force. So 34.64 times by 174.506 must equal 240 multiplied by E. So it's that perpendicular distance by the force and the perpendicular distance of 240 multiplied by the unknown, which is E. And if you put that into your calculator, you quite clearly see that E equals 225.19 newtons. So that's the value over here that we're wanting to know at the end of the day. So you can see how this is actually quite a simple moments problem. And this over here is a fairly simple hydraulics problem. Force 1 over area 1 equals force 2 over area 2. And they often in an exam put these two types of questions together in this example. One hydraulic question and one moments question. Give it a go in your textbook and see how you go.